Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Scott.
And in studio with us we have Gavin. And Gavin, if somebody needed to contact us, what would they need to do?
To contact Do the Math, for math homework help, call in Bakersfield 636-4357 and everywhere else 1-866-636-6284. Our email is dothemath@kern.org and we are online at dothemathonline.net. And find us on social media at Facebook, Instagram, Twitter, and YouTube.
All right, nicely done. Do you have all of that social media stuff for yourself?
No.
Nor do I. But we have for the show.
Yeah.
But you're familiar with all of those things, right?
Yes.
So where do you go to school and what grade are you in?
I go to Berkshire Elementary, and I am in 6th grade.
And they are Eagles, correct?
Yes.
Have you been an Eagle for a long time?
Just this year.
Just this year.
Yes.
All right, so were you going to school someplace other than, like, close to here, or did you move from far away and come here?
We were actually really close. We actually came from Granite Point, which is like the school that is right next to there, just down the road.
Oh, okay, so you didn't move too far to go to schools.
No.
So you're at Berkshire for this year.
Yes.
So what do you like about Berkshire
I feel
that's different than your other school, let's say?
So I feel like I get to learn a little bit more. Like, feels a lot more engaging to me than,
Okay.
like, it's getting a little more challenging, and I like challenge.
Well, good. Well, I'm glad that you're having that this year, because guess what's going to happen next year?
It's gonna go crazy next year.
There you go. Junior high, right? 7th grade is coming up. So is there anything that you're looking forward to in 7th grade other than more difficult work? Is there anything else that you're looking forward to?
Maybe the opportunity to learn more interesting things than what we're currently doing.
Okay. Well, as you keep going through school, you're going to keep learning more and more interesting things, and it'll get a little odder every year as you go on, as all the way through that. What are you working on in math class right now?
In my normal homeroom school, my normal homeroom class, we are currently working on output charts with X and Y, the variables.
Okay, so we may do a little bit of that today. Now, you said in your regular normal homeroom class, so what other class is there?
There's other 6th grade classes, but I go to my class.
Okay, so the other class, are you talking about a GATE class?
Yes.
Because there are students that come in here that are part of that classroom also. And what do you think about that program?
I think it's a lot more engaging than my normal thing, my normal
Right,
class.
you like that kind of stuff. All right, well, it's a good thing you got a good head on your shoulders there, young man. You'll do well today. You'll do well. Anyway, you ready for anything that we do?
Yes.
All right, good. Well, before we get you working, let's first take a look at today's Math in the News. And once again, we are celebrating our 20th season on Do the Math this year. And as part of our 20th season this year, we are taking a look at some of the folks behind the scenes that Do the Math. So you're familiar with me, obviously. You've seen Scott many a time. And during this month, we've been fortunate enough to go behind the scenes to all of the different people that work behind the scenes, not on camera. So we've met audio people, film people, producers, media people, all sorts of people, and we're heading to the final two. This is the final week of Do the Math for our 20th season. And we can see Kiki in here. We met Kiki before, and Jack is over there. Two of our student employees. You were a student at one point.
One day I was.
One day, as I was also one day. But in studio with us right now, we have Brian. And Brian, what is your role with the program?
My role for Do the Math is that I'm the technical director / director. My job is the guy to push all the buttons so that everything that you see at home is controlled by me.
So you are very important to the program.
Kind of, sort of.
Okay.
Kind of, sort of.
A lot of times when people see television shows and movies, they see all of the credits, and before it starts, the last thing you always see is the director, because that's how important the director is to the program. So how long have you been with the program?
15 years, just over 15 years.
There you go. So you've been here a long time.
Oh, yeah. Oh,
So
yeah.
15 years. So how is this different, doing the Do the Math program, different than what you had done in the past?
It's a lot more fun. A lot
Okay.
more creativity,
good.
a lot more creative license that I get to have with what I do. Before, I did a lot of news, technical directing for newscast and things like that, and very regimented, very segmented, and we did exactly what we were supposed to do. It wasn't nearly as freewheeling and as much fun, and not nearly as fun of a host as we've got with you.
Yeah.
You're the best, right?
Thus far for the day. Right? Okay. So anyway, so you work with Do the Math, but
do.
you're an employee of the Kern County Superintendent of Schools office.
Yes, I am.
So what are your other responsibilities with the county office?
We do a lot of production, video production for a lot of nonprofits, internally for the office, and sometimes some other external clients that come there. We put videos together for them to promote whatever it is that they needed to be promoted, basically.
And I know that when we have student guests come in, we always give them a tour of the studio and behind the scenes, and this is the big control room.
Yes.
So if you wouldn't mind, kind of explain to us what we're looking at
Sure.
and kind of a rundown of what you're taking care of a lot of times.
All right. Well, during the show, I've got a lot of sources that I can pick through on the switcher. You can see them right there. We've got camera 1, camera 2, camera 3, all the other cameras that are there. Camera 7, which is the one you're watching right here. And I get to pick between all of those sources, and I get to decide what I want to do based on what you're talking about, what the students are doing, and put that on the air. If I want to go to camera 2, for example, what do we got there? We've got the young man on 2. There he is right there. He doesn't realize, oh, there he is right there. All right, there he is. I'll come back to camera. There he is on camera 1. So I could pick the different sources. We'll come back in here to me, camera 7, with the push of a button. I'll tell John, who's running the camera right there, to get a tight shot on me so I can put my name in, and there's my name at the push of a button. And I'll say, name out, off it goes. So those are the things, those are the choices that I get to have to enhance what it is that you all are doing out in the studio.
And how long does it take to get very good at this? Because somebody can come in and they can kind of watch you a little bit,
Sure.
but there's a lot of controls and a lot of sequencing that's got to go on in your head as things are happening live.
I think that the actual act of doing this isn't that hard, but setting the switcher up for the different effects and the different things that we do. We've got the double box. I'll put that up right now. Well, it'll roll the thing, but you can see it in preview right there.
Okay.
We've got the double. All of that has to be preset ahead of time. We don't do a lot of effect changes, so those stay the same throughout the entire season, so I don't have to go back in there and mess with those too much. But you really, if you're going to do this, pushing the button is one thing and knowing when to go, okay. But to have all of knowledge of this and to be able to set all this up, and if something goes wrong, to be able to get yourself out of trouble, that's the hard thing. And that's kind of a skill that over time that you develop. I'm still learning. I'm not the best that there is, probably never will be, but I can be pretty good because I've worked at it and I've done my best.
And
Jack,
being thrown a lot of different situations helps
Absolutely.
with that.
Absolutely.
So that's one of the skills that you just spoke about. What are some of the other skills that kids might already kind of be good at, but they don't realize it, for building these kinds of things that you're talking about?
First and foremost, teamwork. You've got to be athletes like Jack over there. He's pretty good at being a member of a team. He understands his role and how to do that. He takes direction very well, as does really Joaquin, all of the crew members. They do a really good job listening to what it is that I'm asking them to do. They can't arbitrarily, as a great man once said, this isn't the debate society here. I'm the director. If I need it, Jack, I need a single on one. Joaquin, a little bit more audio on the black mic, whatever. They have to do it, okay? Because the show doesn't come together and doesn't look and sound good if they're not doing what I ask them to do.
So what are the big things that you've seen in the 15 years that you've been here from year 1 to year 20 right now?
I think that the show has become a lot cleaner, a lot tighter in terms of the presentation, I think. And I think that's just a matter of everyone kind of getting better as the years have went along at what we do. We're pretty formatted, not quite like I spoke earlier, not quite like a newscast. But we have a plan, we have a rundown, we have a list, and we know what it is that we're going to do for a given month based on the preparation of that list and the things that you've prepared and Aaron and Kiki have prepared. We know what's going on, and we just kind of tick off that list as we go down, and we know that the show's going to go off according to plan because we planned very well for it.
So Do the Math has been going for 20 years. You've been here for 15 years. And you need to get yourself to 20 years, so we can count on you being here another 5 years, correct?
Not a problem.
Hey, there we go. We'll
Not
end
a
it right there. He said not a problem. So there we are, Brian Puckett, the director, and is it technical director also?
Just call me the director.
That's what I was going to do.
That's
The
what you
director
call me,
of
the
Do the Math
director.
right there. And that is today's Math in the News. And speaking of a lot of different lingo, we'll take a look at today's language of mathematics.
All right, welcome to Language of Mathematics. My name is Mickey, and today we'll be exploring volume. So you might be looking at the board here, and we have two normal types of volume. Everyday use, you might see a dial or some sort of volume adjustment. And on the right side here, we have more of a mathematical volume. So today we're going to be exploring what's the difference. Let's take a look. So the volume, like on your phone here example, if you want to make it louder, the definition is the quantity or power of sound, degree or loudness. So basically how loud a sound is or what it's doing to allow you to hear something. So by adjusting the volume, you can make that degree of loudness increase, meaning you hear more of it, or decrease where it's harder to hear and you're hearing less of that sound. An example could be I increased the volume on my phone so that I could hear the music clearly. Now, it doesn't have anything to do with math, so it's not helping us today. Let's explore another definition and see if that will help us a little more. So the mathematical volume is the amount of space that a substance or object occupies or that is enclosed within a container. So if you think about a box or a treasure chest, everything you can fit inside of it is the volume of that container. One sentence example says the student used multiplication to calculate the volume of the box he was using. So let's see, what does that look like? Why do we use volume? And I'm not talking about the volume on your phone. We're going to stick with the mathematical volume for here. So to find the space inside of objects, like we said, if you have a treasure chest and your goal is to go and raid all the ships on the sea, well, you can only fit so much treasure in your treasure chest, and using volume will help you determine how much space you have. We can discover how much space we need also. If you decide, hey, I raided 12 ships on the sea today and I need 400 cubic feet of space, you need to be able to determine, is your object or container large enough to contain all of that? And finally, we can determine if objects can fit inside of something else. So let's go forward. So how do we calculate volume? Volume is a fairly straightforward example. And for every three-dimensional object, volume has a very standard formula. It is going to be length times width times height. Using these three standard measurements, we can calculate the volume of any prism, any three-dimensional shape for the most part. So here we see we have 5 centimeters, 2 centimeters, and 3 centimeters. The nice thing about multiplication is it doesn't matter what order we put them in. So we could determine anything to be the length, width, or height. So for example, the length this time will be 5 centimeters. So we crossed it out, we've already used it. Maybe our width, we want to choose 3 centimeters, okay. And finally for height, we have 2 centimeters left. So again, calculating volume, we multiply all three of these measurements together. So 5 times 3 gives us 15, and 15 times 2 gives us 30. So we have 30. Now sometimes you might be wondering, Mickey, why sometimes do we put these numbers next to the centimeter? Because I know my measurement is in centimeters, but the question is, why do I have to put all these crazy numbers up there? And students wonder, why do I have to put the 3 up here as the variable? Here's the reason. When you get into algebra and you start working with more of these terms and different measurements, when you are calculating volume, we look and notice, well, hey, I have 3 measurements that are all centimeters. Do you see a correlation there? We use centimeters to the third power because you multiplied 3 centimeters together to get volume. So if no one ever told you why, your teacher tells you it's because, it really is because we have to match our power with how many times we multiplied a measurement together. So that is today's language of mathematics, and hopefully you learned a little something about volume. It's not just on your phone, but it's also the space in the world.
There we go. Today's language of mathematics, also the volume that we have in studio. There's all sorts of things going on, lots of volume all around. So I'm sure that you knew about volume as far as math was concerned, right? Because
Yes.
I know you've done that in class already this year. So let's head over to the board, and we need to put some measurements on here.
Okay.
So what units would you like to use? Feet, inches, meters, centimeters, what would you like?
I'd like meters, please.
Meters. All right, very good. So we have a rather large rectangular prism here.
That's right.
How old are you, Gavin, if you don't mind me asking?
I am 12 years old.
You're 12 years old. Let's make one 12 meters. You're in 6th grade. Let's make one 6 meters. And there are 3 of us on set right now, so let's make the other 3 meters. So Gavin, go ahead, grab a pen and explain to Scott how to figure out the volume first of that prism.
So the formula for volume is length times width times height.
Good.
So we do all 3 measurements. So 12 times 3 times 6. So first we do it one at a time. 12 times 3 is 36 times 6. So to multiply these together, I usually stack them.
Good idea.
So it's a little easier to do.
Yeah, I agree.
Multiply them. 6 times 3 is 18, plus 3, we have 21. So the volume would equal 216 meters.
Now, how many measurements did you multiply together?
3.
Gotcha. And so right at the end of the language of mathematics clip that we just saw, he talked a little bit about multiplying those 3 things together, and we want to make sure that we mirror those 3 in the answer, right?
Yes.
So you said you multiply 3 of them together, so we have to show that somehow in your final answer. You have 216, which I believe is right. Well done on that part. But how are you going to show that you multiplied 3 measurements with meters together? Do you remember what he said?
Length, width, and height.
He did, that's right, exactly it. And you want to make sure that you show that in your final answer. So on the meters, right, on the meters at the very end here, you want to go ahead and put to the 3rd power, or cubed, right? I put that there for you. We want to make sure that's there, because when you're talking about volume, you're talking about the space in the middle. If you just had meters, it would be the length of something, right?
Yes.
Or just the width of something. But we're talking about the space in the middle, so we have to know we have cubic meters. But the math there is really well done.
All right, good. So if one of you guys wants to, above that prism, put V equals 216 cubic meters so we can put volume up there. And then Gavin, if you want to, on the side, everything that's in red that you worked on, go ahead and erase all of that because you're going to need a lot of room for the next part. So Gavin, once we have figured out the volume of that prism, do you have any idea what I would like you to do next?
No.
Take a guess.
Oh, when he says it, you'll know it. What else can we find with the prism?
Area.
What kind of area can we find?
2-dimensional area.
That's right. And the only parts on this shape that are 2-dimensional are each of the sides, right?
Yes.
And we call that surface area, right? We
There
don't
you
know
go.
about
So
the
find
area
the
of all the
surface area, please.
Gotcha. Okay. So if you were going to find the surface area of this picture that we have here, where would you start first, Gavin? What do you want to do first?
I'd go with 3 and 6.
Okay. And what area is that going to give you?
It will give us 12 meters squared.
Multiply. Oh, there you got 18. Gotcha.
18 meters squared.
Gotcha. And that is on the right side, right?
Yes.
So you found the area of the square or the rectangle on the right-hand side there,
Yes.
right? Is that the same as another side?
Yes.
Which side?
It is also the same on the left side. Or
Gotcha. So even though we can't quite
parallel
see it, because we're going to look at it at an angle, the left and the right side are the same because they have the same measurements going up and down, left and right. And so the area or the surface area of those 2 sides is the same, right? Okay,
Yes.
gotcha. What else do you want to find the area of?
Find the area of this side.
Okay, and how would you describe that side to someone? What side is that?
So we'll describe it as the front side.
Good idea. There you go.
So we take the measurement here, 12 meters,
Yeah.
and then it looks like this is the height.
Yep, there you
So
go.
we'll apply this to there.
Good.
So it's 12 times 6.
Uh-huh.
And then that'd give us 72 meters squared.
Good, there you go. So that's the front, and
And
that's
then-
exact same surface area as which side?
The back.
There you go. Front and back are the same, left and right are the same. Okay, what's next?
Then now we have the top and the bottom.
Good. Okay, so what numbers do you have to multiply together to get the surface area of the top of this shape?
12 and 3.
Yeah,
3 is the side here, and 12 is the side over here.
good
We
job.
don't take the height into consideration when doing
Right.
a top.
Yeah,
So
good point.
12 times 3 is 36 meters squared.
So that is the surface area of the top of this figure, and also
The bottom.
the bottom. So we have 3 measurements, but they're actually covering all 6 sides, right?
Yes.
How do you want to find the total surface area of this entire picture?
We multiply all of these, so we multiply 72 times 2,
Okay.
and then et cetera, then we add them all together.
Gotcha. Why don't you do that over there on the left-hand side?
Okay. So we have 72 times 2.
And that's for the front and back. Good job.
Yes. We have 4, 14. So I'm going to put this over here, 14.
Good. So there's the front and the back. Good job.
We're going to go side to side.
Okay, so right and left. Good. So we got the right and left total surface area. Good.
Then
What
we
else
have
is
the
left?
top and the bottom.
Good job. And there's 2 of those sides, multiplying it times 2. Well done. Aha.
Now we just add them all together.
Gotcha. So 4 and 6 is 10, plus 2 more is 12. Oh, I got you. You're carrying the 1. All right, what else? Good.
And then we also need to carry another
Uh-huh,
one.
that's it.
So our volume,
No, we already had the volume.
so our surface area.
There you go. Good for you. And that was a good thing we wrote volume earlier. So the surface area of this entire shape is what we really found, right? I think the math is correct. Nice job. And how do you say that number?
252 meters squared.
There you go. Gotcha. We're square meters. Well done. Really good job on that one.
Now, what I'd like you to do, Gavin, is take a look at that, because what you did is you found one face and then you added it again to get the opposite face, and then you added up all of those. Is there an easier way you think you could do this instead of adding up 72 and 72 and 36 and 36 and 18 and 18?
Got them thinking. That's a good thing in math. Got to make sure that there's other ways to solve problems. And usually we have problems in math that have one answer that really is correct, but there's multiple ways to get there, right? And that's kind of what we're looking at here. The way you did it was wonderful. Can you think of another way that maybe you could get to the same answer?
Maybe we can combine terms.
Okay, which ones could you combine?
Let's see. It seems these two would be a little simpler.
Oh, I see. So if you added them together, then you could put those together first?
Yeah.
How about this? Look, take a look at what happened. What did you multiply all the numbers by?
2.
You multiplied everything times 2, right?
Yes.
So instead of multiplying it times 2 and then adding, is there a different way you can do that? What other number could you multiply times 2 and just do one multiplication problem? In other words, would you agree that the front was multiplied times 2, and the top was multiplied times 2, and the right was multiplied times 2?
Then we could do 6.
So if you added them all together, right? If you added those ones together, then you could just take that new total and multiply times 2 one time. So you could do your adding first, as opposed to the adding at the end. Let's see if it works, okay? Can you do that?
Yeah.
Let's add 72. You can leave that there. That's all right. No big deal. You can add 72 plus 36 plus 18. What do you get? Good. There you go. Gotcha. Now, the theory is if you take the number 126 and multiply times 2, you're going to get 252. Can you work that out for us over there? 6 times 2 is 12. Good. 2 times 2 is 4, plus 1 is 5. And there's your 252. So same answer, but only multiplying one time where you did the addition at the beginning instead of at the end. And there's other ways to do it too. But that's two different ways to get the same answer, and I think you did a good job.
Nicely done. I'm just saying that, bring that up because there's always more than one way to solve a
That's
problem.
right.
And if you can find an easier way, and a lot of times, especially in junior high when you do surface area, you'll get a formula that will say 2 times instead of adding everything up and
Right.
individually multiplying by 2.
Yep.
All right. All right, clear the board, boys. I've got another type of problem for you. This is something that Gavin brought in.
Well done.
So, here we go. I'm going to give you a list of numbers. We're going to do some mean, median, mode, and range.
Okay.
All right, so start all the way over on the left, and we'll put commas between the numbers. Okay. All right. So we have 45.6. See, the decimals is going to make this beautiful. All right, put a comma or something to separate them. 54.6. 44.6.
0.6 is a big hit today.
46.5. 66.4. And the final one is 54.6. So you need to find, so if you want to, down the left-hand side, over on the board, you can write mean. Underneath that, median. Underneath that, mode. And underneath that, the range.
Gavin, we got some work to do here, man. There's a lot of stuff going on there. Which one do you want to tackle first?
Probably mean, as it will be the most time consuming.
Okay, and why is that? What's the process of finding the mean?
You have to add all the numbers together.
Okay.
Then you have to divide it by the amount of numbers there are.
How many numbers do we have here in this list, by the way?
We have 6.
Gotcha, okay. So we're maybe way over to the right-hand side. Go ahead and add them up.
Well, I'm going to do you guys a favor.
Oh, he's going to help us out here.
So at the end of it, let's just go ahead and put what the total is here. So it's 312.3. If you'd like to put a 0 after that, that's fine also, but it's 312.3.
There you go.
Okay.
So I will leave the rest up to you now.
Okay, so what do we do after we add them together?
We divide by 6.
Oh, there you go.
As it is the amount of numbers there are.
Okay, good deal.
6 divided by 30. Okay, should get 5.
I really like how you put the 5 over top of the 1. That's a good job there.
12.
So 6 goes into 12 twice. Good job. And brought down the 3. Got the decimal there. Good job. Now that's a really important part, right? You got to make sure you add that 0 there because 6 doesn't go into 3 at all. And even though you're going to bring down the 0, you got to make sure you have that space holder there. Good for you.
All right, and we are done.
52.05 as the mean. You want to go ahead and put that on your list there?
Yes.
Now let's make sure that answer makes sense. Look at your list of numbers. Would that number, 52.05, would that fit in your list somewhere? Is it somewhere within the range?
Yes.
It would, right? So if you had a number at the end that was like 520.5 and you looked at your list, you could maybe see that number is way too big. Maybe I should check my decimal place. So it's always good to have an idea about where it should be, right?
Yes.
So I just talked about the range. How do you find the range? What is the range of these numbers?
The range is the largest number in the data set subtracted by the smallest.
Gotcha. Okay, so let's do that one next.
So
So what is the largest number?
looks like it is 66.4. Process of elimination. Looks like it's 44.6.
Good, there you go. So we're just trying to find the difference between the biggest and the smallest number, right?
Yes. Looking
good. 21.8. So go ahead and put that on your list. Now we did these a little out of order from the way that I usually teach my students to do this, but there's no problem. Everything's been done right so far. When you first see a list of numbers, when you very first start a problem like this, what do you think is probably a really good thing to do before you start any of the math?
Rearrange them so it's smallest to biggest.
That's it right
biggest
there.
to smallest.
So let's do that. Okay, way over on the right-hand side, way over on the right, past your division. Let's go ahead and put them in order from the smallest at the top of the list to the biggest at the bottom. So what is the smallest number? 44.6. And if we'd have done this at the beginning, it would help a little bit with the range, right?
Yes.
Yeah. I really like how you cross it off too, so you know that that number's already been used. 45.6 is next. Good job. And 46.5. Good work. So far, we got them in the right order, even though they're using the same numbers almost repeatedly. What's next?
Looks like we have the same.
Uh-huh. And when you have a list of numbers like this, you're allowed to have more than one of a specific number, right?
Yes.
So you got 54.6 twice. And the last one? 6.4, good. So you had 6 numbers at the beginning, we still have 6 numbers now. We haven't changed anything, we just put them in order from smallest to biggest. Which one of those words will that help us find?
This will help us find the median.
The median. What is the median?
The median is the average in a data set.
Well, we already found the mean. That was the average. I
Oh,
totally agree with you
sorry.
there. But
It
what's
was-
the median part?
It is the middle of the data
The
set.
middle. Okay, how do you find the middle? What's the best way that you know how to find the middle of this group?
So always count down from both sides. So 1, 1, 2, 2, 3, 3.
Ah. So what do we do now? There's no number right in the
Yeah.
middle. I like what you said. There are 6 numbers, right? So you counted down 1, 2, 3, and 1, 2 here, and you want to go 3, but it goes right there, right in the middle. There's nothing there. What do we do there?
There's a simple solution.
Okay.
So we add both numbers together.
Okay. $46.5 and 54.6.
Just add them.
Okay, so we're adding them together.
So we get 101.1.
Gotcha.
Now we just need to divide it by 2.
Now
since
don't
there-
forget that part, right? Because we
Yeah,
want to make sure
'cause
that
there's 2.
number ends up in the range somewhere, right?
Yeah.
And that'll become 50.55.
Aha. So go ahead and put that down for the median, 50.55. And that's the number right in the middle. So that's one of the few numbers, right, that's not even in the list, but we can find it. The last one, mode, how do you remember what the mode is?
The mode is the number that appears most in the data
That's
set.
it. The mode is the most, right? Which one
Yes.
appears most often here?
54.6.
That's it. No math necessary there. You just got to be really observant about what's going on. Good job. And those are your 4 statistical numbers that you need to find on this one. Nice job.
Yeah, well done right there, especially with the decimal points in there. Makes it a little bit more difficult because you really need to watch what you're doing. We do have phone tutors available until 5:30. As a programming note, this is the final week of Do the Math this year for our 20th season. We will be ending on the 23rd, which is tomorrow. That will be the final live broadcast for Do the Math this year. Gavin, for doing some great work so far this afternoon. You've got yourself a meal courtesy of our friends at the Broken Yell Cafe, so congratulations on that. Have you been to the Broken Yell Cafe yet?
Yeah, once.
Oh, good. Well, you're going to go in again. Hopefully you found something you like. If not, try something new. I'm sure you'll like that also. We'll be back with more right after this.
I've always wanted to be on the ocean. Since I was 12, actually, I wanted to work for NOAA. My name is Allison Stone, and I'm a hydrographic senior survey technician on board the NOAA ship Thomas Jefferson. My primary job on this ship is to make sure the ship is seeing the seafloor exactly how the seafloor is. So on a day-to-day basis, I'm doing anything from acquisition or processing data, reporting, analyzing the data. 601. But I'm also, as a senior technician, in charge of maintaining equipment on a regular basis. You're running the systems, you're making sure everything is working, everything is happy. As we like to say, all the sonars and all the equipment is talking to each other, and just generally making sure that the data coming in is good. Because if that's not the case, then the data coming out won't be good either. What I love about my job is that every day we get to see things that nobody has seen before, or in ways that nobody has seen it before. We see images of wrecks that are so precise that it's almost like the ship is coming back to life. Very few people ever get to experience that. Being on a scientific vessel and working and living very closely with your coworkers creates an interesting environment. It's not like an office, or it's not like somewhere where you get to go home at the end of every day. This is home, and the crew really becomes a family. And we all look out for each other safety-wise. If you need someone to fill in for you, you help your crewmates out. For anybody interested in science, or who loves science and math and the environment, oceans, atmosphere, anything, NOAA has something for you. It's a great way to pursue your passions.
In the waters off of Martha's Vineyard, the Office of Naval Research is using unmanned and robotic systems to investigate how sediments on the ocean floor are moved around by currents and waves. Coastal storms often stir up sediments, creating a turbid layer of bottom water that can be difficult or impossible for Navy sensors and divers to see through. The problem is not easy to study using traditional ship-based approaches, so Navy scientists are developing and employing robotic observation systems. Some of these sampling systems are designed to monitor water column and ocean floor properties at fixed locations. The Martha's Vineyard Coastal Observatory, operated by the Woods Hole Oceanographic Institution, is connected with cables to laboratories onshore where scientists can control the sensors and study ocean conditions as they occur. One advantage to this approach over ship-based studies is the ability of these robotic systems to operate during storms when it would be too difficult or dangerous for scientists to work at sea. Some of these robots are like small submarines that are able to move around under their own power.
Gliders are an AUV, an autonomous underwater vehicle, and it's kind of unique in the AUV world in that most vehicles are driven by propellers, but gliders are actually using a buoyancy drive to create forward propulsion. So I view these AUVs, or autonomous underwater vehicles such as the Ocean Glider, as a complement to today's boats and other structures where they're enabling us to say, okay, there's a place of interest that we'd like to go look at out here. They're doing these border patrols or boundary patrols.
As these systems become more capable, they will provide future scientists with the tools to unlock secrets of how the ocean works and to understand processes that scientists today are only beginning to realize. It's truly an exciting time to be an oceanographer.
Well, an exciting time to be an oceanographer right now, and I would imagine in a few more years from now, even more exciting as we learn to explore more about the world below the surface of the ocean. We do have phone tutors available until 5:30 most Tuesdays and Wednesdays throughout the regular school year. As part of our 20th season this year, we're fortunate enough to have the Bakersfield Museum of Art come in once or twice a month and work with some of the students and apply art and mathematics at the same time. In studio with us, we have Lucia. Lucia, how are you this afternoon?
I'm doing well.
Thank you. And what is your role with the museum?
I'm an art instructor at the museum.
And how long have you been with the Bakersfield Museum of Art?
Only about like 6 months now.
All right, so you're brand new and they said, hey, go do this math lesson on live TV, huh?
Yeah.
So what are you going to be doing today with Gavin?
I'm going to be working with parallel lines and perpendicular lines, and we're going to be going over an abstract piece.
All right, as soon as you guys are ready, go to it.
Okay. So we're going to be using the rulers and using the line to then create parallel lines across the page. And parallel lines are lines that are exactly straight to each other, so you want to make sure that they're completely next to each other. And then we're going to be drawing some perpendicular lines, which will cross over and just touch right here. And you can really just put them wherever you'd like. And after just having a few sections crossed out, we can start moving on to the paint. So you don't have to fill up the whole page if you don't want to. And once you have a few, you can grab your paintbrush. I'll wait for you to do a few more. Once you have a few on there, you can start painting onto the sections and leave out the white sections.
Okay.
And you can water down the paint too with some of the water here. Have you ever done an abstract piece before?
Yeah.
Do you like, do you like art that's subjective like abstract, or do you like realistic art?
Kind of like abstract.
Alright, so once you have your sections off, you can just choose whichever section you want to do in certain colors.
Okay.
And I have these colors here. There's also a purple if you want to use the purple.
Okay.
And you would just be sectioning it off. And you want to leave those lines that we drew empty, because we're going to be going over those in color pencil and marker. So the little sections that we did. And you can mix the colors too if you want. And since it's abstract work, you don't really even have to do the whole entire thing, because we can use a different material to cover those areas that are a little bit white. So I'm just going to leave mine like this and keep adding on the other sides. Do you have a favorite artist?
No, not in the moment.
And if it's okay if it gets messy too, because since we are using other materials, we can layer on top of it.
Okay.
Have you ever gone to a gallery before?
Gallery? I don't think so.
No? If you need more of a specific color too, I can pour you some more out.
Okay.
I know you were using blue.
So Lucia, we can see that Gavin is doing a little bit more detailed in his art project right there. So what comes next after the paints?
After the paints, we would go in with the colored pencils or markers and just outline some of the outside of the lines out here. And we can section them off. And inside the lines, we can choose a different color too to create more parallel lines in here.
So even though you may not be through painting, Gavin, you could probably go ahead and outline with marker on the lines and kind of follow along with Lucia a little bit right there. And you can finish up at home or in school later on.
Okay.
And that will give your paint some time to dry too. So I'm doing a bunch of like parallel lines inside as I go, just because later on it gives it like this really intricate kind of visual to the eye. Once you're done with the lines, and you get to this step, what I like to do is do shapes inside the sections. It's okay if you're not on the step yet. I try to use like one of the colors that I haven't done in that section.
And so once that's complete, Lucia, what is the next step in that?
After I've drawn out the shapes, I like to let it dry and then go over it some more with the markers on top or with the Sharpie that I brought to kind of either like give it a spotty look or some linear designs on the sides just so that there's more going on and there's like playing around with some of the curvy lines instead of just them being completely straight. And if you don't want to do like geometric shapes, you can do organic shapes, which are really loose form shapes. And you can mix the colors too.
And as you're getting ready to wrap up, Lucia, I have a question for you because you had asked Gavin who his favorite artist was. Do you have a favorite artist?
Yeah, my favorite artist is Frida Kahlo.
And why is that?
Frida Kahlo has always been a really huge inspiration to me, and she had an accident at the age of 18 that left her paralyzed. Well, it was supposed to, but she actually learned how to walk again after trial and error multiple times with the help of her sister. And the body cast though left her in the body, or the accident left her in a body cast for 3 months. And I actually have been in an accident that left me in a body cast for 3 months, so I always really related to her and her work, and she's always just been a huge inspiration to me.
All right, well, I know that you and Gavin are going to continue working on this a little bit, but before you guys keep working on it, Lucia, if somebody wanted to know more about the Bakersfield Museum of Art, where would they need to go to?
They would want to go to bmoa.org, and on our website they'd be able to find information about events that we have going on, like the Art After Dark or our Art Mix event that's coming up soon.
All right, and you spoke about different events going on. I know that you're involved with a show coming up also, right?
Yes, so I'm actually going to be having my first ever solo show soon at CSUB at Cal State Bakersfield in the White Gallery, and it's going to be on the 28th and the 29th, this Monday and Tuesday coming up.
All right, fabulous. Well, Lucia, thank you for coming in, being part of our 20th season. Gabby, you continue working on that, and we'll be back with more right after this.
The deep ocean, a place so different, filled with strange life forms. But what's down there? How much do we know about it? As it turns out, not very much. 95% of the ocean remains unexplored, most of which is considered the deep ocean. But what exactly is the deep ocean? The first 200 meters of the ocean are the open ocean. Much of the marine life we know of lives here, where there is light. Below 200 meters, where there is little light left, you enter the twilight zone. Once you pass 1,000 meters, the water is completely devoid of light, and you have reached the deep ocean. Down here, temperatures plummet to 39 degrees Fahrenheit and constantly stay near freezing. The pressures at these depths range from about 40 to over 110 times the pressure of Earth's atmosphere. But how could anything thrive in these conditions? It was originally thought that life cannot survive without light. We now know that despite this lack of light, many creatures can live in this extreme place, such as microorganisms in hydrothermal vents, deep-sea corals, fish, and many other bizarre creatures. Exploring the deep ocean is challenging because of the harsh conditions, but marine scientists are on a mission to document new species in this unusual place.
There's another world beneath the ocean's surface. Come join us as we explore the depths below. We know the Earth isn't flat, in any sense of the word. We see mountains, valleys, hills, and holes. And the seafloor is just as diverse a landscape. But did you know that in certain places on the seafloor, like in the Gulf of Mexico, there are even underwater lakes and rivers? How is that possible? Well, these lakes and rivers form when seawater seeps up through thick layers of salt, which are present beneath the seafloor. As the water seeps up, it dissolves the salt layer, causing it to collapse and form depressions. The dissolved salt makes the water denser, And because it is denser than the water around it, it will settle into the depressions, forming a river or lake. These underwater lakes and rivers can be as small as a few feet across or as large as a few miles long. They're even very similar to lakes and rivers on land, with shorelines, surfaces, even waves. And there are even some creatures that enjoy hanging out by these lakes, like underwater beach bums. Huge fields of mussels are found growing along the edges of some of these lakes, but they're not exactly sunning themselves. This far beneath the ocean's surface, sunlight is extremely hard to come by. As we know, sunlight plays an extremely important part in the food chain here on land. But this far down, organisms like these mussels have adaptations that allow them to get their nutrients from bacteria that can convert methane and other chemicals in the salty water into energy. While we've come a long way in our understanding of the ocean, most places are still unexplored, and many questions are unanswered. So join us as we explore the depths below.
And once again, we do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. Programming note, tomorrow, the 23rd of March, is our final day for Do the Math for our 20th season. That will be the last live broadcast for year number 20. In studio, Gavin, a 6th grade student from Berkshire Elementary, likes being an Eagle, and you're looking forward to junior high, right?
Yes.
All right, some more difficult work coming your way, especially. Right on over to the board, young man. Draw a square in the middle of the board for me, if you would. And on each side, the left and right side, draw a line going into the square and a line coming out of the square. So draw one line going into it and one line coming out of it. There you go. All right. So you're going to have to figure out what's going on inside that square. Pretend it's a machine. On the left-hand side, let's put 12. So on the left, outside the square, over by the line. All right. So we'll put 12 over there. And on the other side, on the right-hand side where Scott's got his marker, let's put 36. So, Gavin, if 12 went in and 36 came out, what could possibly have happened?
There are many things that could happen, possibly an infinite amount. It could be multiplied by 3, it can be multiplied by 4, and subtracted by 12.
Okay.
It could be multiplied.
How about if you just added? What would happen there?
If we just added, we need to add 24
Good
to
job.
get 36.
Well done. Lots of different things that could happen there. I like
Yes.
that.
Right, you've got 3 different things right there.
Yep.
All right, good. So, Gavin, go ahead and erase the 36. And let's make it a 6. Tell me one thing you could do.
Divide by 2.
There you go. That's it. Easy enough, right?
Well done.
So, Gavin, did you learn a little something today?
Yes.
Did you have fun today?
Yes.
That's exactly what we wanted right there. Hey, do remember we have phone tutors available until 5:30, and until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.